Assalamualaikum warahmatullahi wabarakatuh. Okay, today we discuss about lecture 7 and lecture 8 for part 2, which is we cover about recursion. Previously, we have done the mathematical induction. Okay, for the mathematical recursion, the topic will be recursive function, recursive definition, and defining recursive definition. Okay, here is mathematical induction that we learned previously. So for mathematical recursion function, okay, as a definition, sometimes it is difficult to define an object explicitly. However, it may be easy to define this object, function, sequence, algorithm structure in terms of itself. This process is called recursion. For instance, the picture shown here is produced recursively. Okay, look at this example. This is the biggest one is the original picture. First, an original picture is given. Then a process of successively superimposing centered smaller picture on the top of previous picture is carried out. Okay, what is recursion? Recursion is we do from the translation, we know the recursion is pengulangan. We ulang sesuatu maklumat tetapi dengan ada perubahan sedikit. Okay, for example, the original one is the biggest picture. Then we do the recursion, which is we make it smaller, but we use the previous information. Okay, that's what we call recursion. Then we repeat it by using the previous information. We small the resolution until we get the end resolution that we need. That's the example of recursion function, which is pengulangan. Okay. When we define a set recursively, we specify some initial element in a basis step and provide a rule for constructing new element from those we already have in the recursive step. We use two steps to define function with the set of non-negative integer, which is for this recursion function we must have basis function and we have the recursive step. Okay, like previous mathematical induction also have basis function, then it have the induction function, right? Okay, now we have the recursive step. We call this definition as recursive definition. That's the what the important thing that we know that we have to know in this lecture, which is the basis step and the recursive step that we create. Okay. For example, here arithmetic sequence. Okay. This is the recursive definition, recursive step, and this is the basis step. For the geometric sequence also, this is the example of recursive step, and this is the initial step. Same goes to factorial function and Fibonacci function. Actually, we can get the value here by replacing the formula. Okay, for the example, let me see. Example 3. Suppose that f is defined recursively by f0 is equal to 3, then fn plus 1 is equal to 2fn plus 3. Okay, this is the example of, this is what we call the basis step, and this is what we call the recursive step. Okay, how can we get the set of function by using the basis step and the recursive step? Okay, here we can know we can create the set of function, a set of value by using the formula given. Okay, we know that f0 is equal to 3. How to find the f1 here? Find f1. Okay, f1 is equal to f1 is equal to 2f0. How can we get 1 here and we get 0 here? We know that f1 from here, f1 is equal to, okay, look at the number inside the bracket, which is this is 1, right? And this is n plus 1. Then we know that n plus 1 is equal to 1 because of n plus 1. And then we want to find 1. So now we know that our n here is 0, which is when we find f1, our n is 0, which is f1 to f0, because in here we have to replace n value. N value it become 0 from this value. So replace f1 is equal to 2f0 plus 3. Okay. How can we get the value of f0? Then f0, we get the f0 from the initial value. If f0 is equal to 3. So now 2 times 3 plus 3 is equal to 9. Okay, uh, same goes to f2. Here, if you want to find f2, okay, if we want to find f2, so now our value here n plus 1, it become 2 because of f2. This is n plus 1. Okay, so n is equal to 1. So f2 is equal to 2 from this uh, from this equation. This equation, we know that f2 is equal to 2f1 here, and our n is 1, right? Plus 3, which is 2 f1. The previous value, we use the previous value, which is f1 is 9, right? Just replace it here. 2 times 9 plus 3 is equal to 21. Okay, for f, same goes to f3. We know that when n is equal to 3, so n plus 1 is equal to 3, then n is equal to 2. So 2 f2 plus 3 is equal to 2 times 21 plus 3. How can we get f2? We use the previous value, which is 21, plus 3 is equal to 45. Okay, same as f4. If we want to find f4, we use the previous value, which is n plus 1 is 4, then n is 3. Okay, 2f3. Then we use the f3 value here, just replace it here, then 2 times 45 plus 3 is equal to 93. So here is what we call the recursively, which is pengulangan by using the previous information. Okay, next, for example 4, here, given recursive function of factorial number. Okay, for this example, n factorial is equal to 1 for n is equal to 0. Okay, here is the basis step. And you know that the recursive step is n factorial is equal to n times n minus 1 factorial for n is greater or equal to 1. So find for this question, find the value of factorial when n is equal to 1, 2, 3, 4, and 5. Okay, for n is equal to 0, we know that it's the basis step, which is n is equal to 0. Then just replace here, which is n is equal to 0. Here is n, then replace it with 0 factorial. 0 factorial, use your calculator, then you get 0 factorial is equal to 1. Okay, so now we find n is equal to 1. When n is equal to 1, then n here, just replace it. N is equal to 1. Then 1 minus 1 is become 0. 0 factorial. Okay, so 0 factorial previously, if you don't want to use your calculator, you already know 0 factorial, we get it from the previous value, which is 1. Then 1 times 1 is equal to 1. For n is equal to 2, just replace this recursive step function, which is n is equal to 2, then 2 factorial is equal to 2. So n here it become 2 and n minus 1, which is 2 minus 1 is equal to 1 factorial. Okay, then 1 factorial, here we use the previous value. Previously we have already know 1 factorial is equal to 1. So replace it. 2 times 1 is equal to 2. Okay, same as n is equal to 3. 3 factorial. So now this is 3 factorial. Then is equal to, our n here is 3 times 3 minus 1 is equal to 2. Okay, 2 factorial. We get the 2 factorial value by using the previous information, which is 2. So then 3 times 2 is equal to 6. Okay, here we know that in order to get the current value, we use the previous value, right? This is what we call recursive function. Okay, when n is equal to 4, just replace 4 factorial is equal to 4. 4 minus 1 is equal to 3 factorial. So then 3 factorial, we get it previously is 6. So 4 times 6 is equal to 24. Okay, for n is equal to 5, here 5 factorial is equal to 5 times 5 minus 1 is equal to 4 factorial. Then we use the 4 factorial previously information, which is 24, replace it here. So we get 5 times 24 is equal to 120. Okay. This is how can we get the set of value. Okay. So now for example, okay, so here is how can we create the recursive function. How can we create the rule for recursive definition? We have explored how function can be defined recursively. We now turn our attention to how set can be defined recursively. Just as in the recursive definition of function, recursive definition of set have two parts, which is basis step and recursive step. In the basis step, an initial collection of elements is specified, which is previously we know that the nombor yang pertama tu is a initial collection, which is the basis step. Okay, if it begin with 0, so F0 it's become the basis step, or if it begin with 1, F1 is become the basis step. Okay, in the recursive step, rule for forming a new element in the set from already known to be in the set are provided. Okay, so now this is the challenge that we have to know, which is we have to create a rule for recursive function. Okay, for example 5, okay, define the function. So now we know that this is our function fn is equal to 2n plus 1. So for n is equal to 0, 1, 2, 3. This information is really important because of we want to know our basis step. So now we know that our basis step begins with n is equal to 0. Okay, so this is the threshold that we have to do, which is f0 is equal to, okay, f0 n is equal to 0. Okay, so just replace it with 2n. So now our n is 0, right? So then 2 times 0 plus 1 is equal to 1. Okay, done for the first value. Okay, So F1. So F1, 2 times 1 plus 1. 2 times 1, because of our n is 1, so 2 plus 1 is equal to 3. Okay, so for F2, it is 2 times 2 plus 1. Just replace n with 2. Okay, so we get 5. Okay, for F3 is equal to 2 times 3 plus 1 is equal to 7. And for F4, which is 2 times 4 plus 1 is equal to 9. Okay, so now how can we get the basis step and recursive step? So now we know that our basis step is F0 is equal to 1. This will become our first basis step. Okay, so here what you have to know is how to create the recursive rule. Okay, the recursive rule, we can get the idea from this value. Okay, if you don't get the pattern yet, you can find F5, F6, F7, F9, it depends. Okay, so how can we get the pattern to create the recursive step? Okay, so this is F1. Okay, the idea is check the difference. Okay, what is the difference with the previous and the current value? For F1, we know that the difference is 3 minus 2, right? 3 minus 1. Okay, meaning that here we get the 3 minus 1. 3 minus 1 is uh, 3 minus 1 is 2. Okay, so 5 minus 3 is 2 also. 7 minus 5 is 2. And 9 minus 7 is also 2. So when n is enough, if we get uh, if we find until F4, because we know already the pattern. So it is what can we conclude here? We use the previous information, then we plus with 2, we get the current one, which is we use the F0. We use the F0 plus 2, we get 3. Then we use the previous value F1, F1, which is F1 is equal to 3. We plus with 2, we get the 5 for the current value. Then same as F3. F3 is equal to, we use the sorry, the F2 plus 2, then F2 is 5, 5 plus 2 is 7. Okay, same goes to F4. F4 we use the value of F3 plus 2. Okay, so how can we get the formula? Okay, the formula is, we know that when n is equal to, okay, this is the basis step, right? Okay, look at the first iteration, which is F1. We find F1, which is F1. F1 is Fn plus 1 is equal to, we use the previous one, right? f n plus 2. Okay, this is the recursive definition, which is we use the how to find f2. F2 is n plus 1 is equal to 2, which is our n is 1. So f2 is equal to f1 plus 2. Just replace it, then we get this. So to find f3 is equal to f2 plus 2. f2 plus 2, then we get this. So for f4 is n plus 1, which is n is equal to 3. Which is f4 is equal to f3 plus 2. Then we get this. So the general, which is formula yang kita boleh rumuskan, yang kita dapat untuk recursive ni ialah fn plus 1 is equal to fn plus 2. Okay, kita tengok dia punya cara macam mana dia selesaikan. Ini example 5. Okay, after this is the previous example, fn plus 1 is equal to n0, 1, 2, 3. So after we get this value, then we see the difference, then we know that this is our basis step, and by using this value we can conclude just now that our recursive step is fn plus 2. Okay, so if we replace it again, then we get this value. So we know that the recursive formula that we create is true. Okay, so this is example 5. For example 6, okay, this is example 6. Same as example 5, which is we have to find the set first in order to get the idea for creating the formula. Okay, for n is equal to n square, for n is equal to 1, 2, 3. So from here we already know that this will become our basis step, which is a1. Here, replace 1. We not begin with 0 because it is not starting from 0. So for an, which is n here is 1. So a1 is equal to n square, which is 1 power of 2. And we get 1. For a2 is equal to our n now is 2. a2 is equal to 2 power of 2 is equal to 4. Then a3, just replace it to this value. So then a3 is equal to 3 power of 2 is equal to 9. Then a4 is equal to 4 square is equal to 16. Then a5 is equal to 5 square is equal to 25. Okay, from here, same as previous, we have to find the different. Okay, so this will become our basis step. Okay, then the second iteration is we know that we use the previous value, which is a1, then we plus 3, it becomes 4. Then for here, we use the previous value a2 plus, what is it? 9 minus 4, 5. Okay, for this, we use the previous value a3. Okay, a3 16 minus 9 will become 9. 7 plus 7. Okay, we can check 9 plus 7, it becomes 16. So our idea here is correct. Okay, so for this A3, for A5, we use the previous value, which is A4 plus 25 minus 16, 9. Okay, how can we create the formula? So we get the idea here is 3, 5, 7, 9. Okay, so if our n is 2, here our n is 2 and uh, when n is 2, so it will become a n plus 1 is equal to then a n plus 1, which is n sama juga dengan 2. Okay, n sama juga dengan 2. Kita guna previous value. Previous value dia ialah a n. Okay, a n. So macam mana kita nak dapat 3, 5, 7, 9? Okay, kita tahu bahawa our n is 1 now, right? Okay, so how can we get 3, 5, 7? How can we, this is what we call the odd nombor ganjil. Nombor ganjil ialah, kita tahu nombor ganjil ialah bila kita masukkan 1, macam mana kita nak jadikan 3. So kita tahu n kita, macam mana kita nak, maksudnya kita tahu bahawa how can we produce 3 from the 1 and is 1, right? Okay, so kita nak jadikan 3. Okay, our n now is 1. Okay, kita tahu 2 kali 1. 1 is our n. Tambah 1 dapat 3. So kita boleh uji pula. Bila n sama juga dengan 2. 2 kali 2 tambah 1. Kita dapat 5. So kita dah selesai untuk 2 ni. So kita boleh check. Bila n sama juga dengan 3. 2 kali 3 tambah 1 sama juga dengan 7. Sama juga bila n sama dengan 4, 2 kali 4 tambah 1 kan 9. So kita boleh concludekan dekat sini, which is 2 times n plus 1. Okay, this is our recursive step, which is kalau kita masukkan balik a n plus 1 bila n sama juga dengan 2 sama juga dengan a1 tambah 3. So bila n sama juga dengan 3 sama juga dengan a2 tambah 5. So kita boleh check. Kita dapat balik yang ni, dan yang ni dan seterusnya. Okey, macam mana kalau ada soalan dia tanya John, kita nak tahu kita nak buat sampai A1 ke sampai A5 ke. Ni terpulang. Kalau selagi kita tak dapat pattern, mungkin kita kena buat lagi so that kita boleh nampak pattern yang kita create ni, kita dapat idea. Okey, so sekarang done by show the basis step and the recursive step. Okay. This is example 6. Okay, this is the how orang ni dia buat, which is dia dapat daripada recursive step tadi, iaitu maksudnya recursive tu dia perlukan basis step daripada nilai awal yang kita dah create tadi. So dan yang ni kita dapat dia punya rule dekat sini an. Okay. Okay, so an kuasa 2 tambah 2n tambah 1. So kita dapat value tu. Okay, so for example 6. So for example 7. Okay, example 7. Define a recursive definition of sum of first and positive integer. Okay, for Fn is equal to, okay, apa dia simbol ni? Simbol ni ialah, kita kata sebagai summation. Ni ialah summation. Apabila 1 sampai n, I. Okay, apa yang dimaksudkan dengan summation ni ialah bila n here, n sama juga dengan 1, maksudnya dia ialah 1. Okey, sama juga dengan 1. Bila n sama juga dengan 2, summation is tambahkan. Okey, bila n sama juga dengan 2, kita kena tambah 1 tambah 2 sama juga dengan 3. Okey, bila n sama dengan 3, kita kena tambah 1 tambah 2 tambah 3 sama juga dengan 6. Macam tu juga. Bila n sama juga dengan 4, 1 tambah 2 tambah 3 tambah 4 sama juga dengan 10. Okay, same goes to n is equal to 5. Okay, so now, like previously, we have to check the difference. Okay, what is the difference? The current one with the previous one. Okay, first, we know that this will become our basis step, and how to find the formula for recursive here. We know that we use for n. The previous n1, which is kita guna F1. Apa beza dia dengan yang sebelum tu? F1 kan 1. Okey. 1 tambah 2 akan jadi 3. So yang ni ialah F guna yang sebelum tu, which is F2 ialah 3 tambah, okey, 3 tambah 3 akan jadi 6. Okey, macam tu juga yang ni, which is yang ni ya. Ni ialah kita guna previous value F3 tambah F3 ialah 6. 6 tambah 4. Okey, dan yang bawah ni ialah F5. 5 plus tolak 10 ialah 5. So kita nampak tak kat sini pattern yang kita nak cari, which is dia mula dengan 2, lepas tu 3, 4, 5. So now we know that when n is equal to 2, our n1, n1, macam mana 1 nak jadi 2 daripada 1? Okey, macam mana nak dapatkan? Okey, kita ada nilai n sama dengan 1. 1 nak jadikan 2, dia boleh juga 2 kali 1 kan? Tapi sebabkan kalau kita nak bila n1, bila yang kedua ni kita test bila 2 kali n kan. Okey, bila 2 kali 1 dia betul, dia akan dapat 2. Tapi bila 2 kali dengan 2 dia akan dapat 4. So how can we get this? Macam mana kita nak dapat idea tu? Macam mana kita nak dapat 3? Okey, dia ialah macam mana nak dapat 3? Okey. 2 kali 1. Okey, macam mana dapat 3 dan macam mana 2, 3, 4, 5. So, 2 kali 1 ialah 2. 2 kali... Okey, so kita tengok. Orang ni. Okey, maksudnya kita tak boleh kali. Kita kena dapat n campur 1. Iaitu, bila n campur 1, yang tadi kan, n campur 1, kita akan dapat 2 kali 1 ialah 2. 2 tambah 1, 1 tambah 1 ialah 2. Lepas tu bila n sama juga dengan 2, 2 tambah 1 ialah 3. Bila n sama juga dengan 4, 2 tambah 1 ialah 5. Okey, apa yang saya cakap ni ialah ini tadi. Yang ni kan, kita dapat dia punya recursive function ialah recursive function dia ialah f n tambah 1 sama dengan F N. Dia punya previous value. So 3 tolak 1 ialah 2 kan. Okey, dia ialah Fn tambah N tambah 1. This is the recursive step. Which is apabila kita nak cari N3, kita guna value N2 which is 3. 3 tambah 2 tambah 1 kan 3. 3 tambah 3 kita dapat 6. Lepas tu untuk dapatkan F4 kat dalam ni N dia ialah 3. Jadi F3 ialah 6. So 3 tambah 1 ialah 4. 6 tambah 4 kita dapat 10. Macam tu juga N5. Which is bila kita nak cari N5, kat sini N5. So N dekat dalam ni akan jadi 4. Okey, jadi bila F4, kita tahu F4 kita tadi ialah 10. So 10 tambah 4 tambah 1 ialah 5. 10 tambah 5 kita dapat 15. So betul lah kita punya recursive step yang kita create ni. Okey. Okay, this is the example 7 just now. Okay, this is what we have covered for today. Okay, so recursive function, which is recursive definition and recursive defining recursive definition. Okay, here we know that we have to find two things, which is basis step and recursive step. So look at the example here. I provide you two examples. How can we get recursive definition from this value? Okay, like previous example, we have to create a set first. Okay, Fn. Fn plus 2 is equal to n is equal to 1, 2, 3. Okay, so we know that we will start with 1. Okay, so F1 is equal to 5 times 1 plus 2. Just replace 1. 5 kali 1 tambah 2, kita akan dapat 7. Okey, untuk F2 sama juga dengan 5 kali 2, sebab dia yang keduanya ialah 2. Okey, tambah 2. Mana kita dapat 2? Sebab kita tengok equation yang asal ni. Okey, sama juga dengan 5 kali 2, 10. 10 tambah 2, 12. Okey. Okey, for F3, is equal to 5 times 3 plus 2. Just use the original equation, which is 5 times 3, 15 plus 2 is 17. Okey, kalau kita rasa kita dah tengok pattern dia, so kita tak perlu sambung sampai F4, F5. Okey, so look at the pattern here. Okey, to be safe, we produce until F4. F4 is equal to 5 times 4 is 20 plus 2 is 20. Okay, now we see the different. The hint is to see the different. Okay, this will be our basis step because it begin with 1. This will be our basis step. And our okay, how to find the recursive step? This will become F1. F1 is 7. 7 minus 12 minus 7 is 5. Okay, and this will become, use the previous value, which is F2 F2 is referring to F2 here. Okay, so F2, how can we get 17, which is 17 minus 12 will become 5. Okay, same goes to here, which is use the previous value F3, F3 and 5 is equal to 22. So here more easier because we know that it is 5, 5, 5. So then we don't have to create a formula. So we know that f n plus 1 is equal to previous value f n plus 5. Okay, so this is our final answer for the recursive step. Okay, so this will be our basis step. Okay, let me see the next example, which is give a recursive definition with initial function. So same here, we have to give all the value, replace n is with, okay, now we know that our iteration will begin with 0. Okay, so now f0 is equal to n factorial, which is f0 is equal to n factorial, 0 factorial. 0 factorial is 1. Okay, for f1 is equal to 1 factorial. This 1 factorial is 1 also. Okay, for f2 is equal to 2 factorial. Okay, so we can find the factorial in your calculator, or if you want to know the factorial is when it is 2 factorial, it is equal to 2 times 1, which is it is 2. When it is f3 3 factorial, it is equal to 1 times 2 times 3, it becomes 6. Okay, for f4 is equal to 4 factorial. 1 times 2 times 3 times 4 is equal to 24. Okay, so now we see the difference in order to get the pattern. Okay, this will become our basis step. Okay, so here, how can we get 1, 2, okay. Okay, so sekarang ni, ini ialah guna previous value. F0 tambah kosong. Sebab kita F01 kan tambah kosong ialah 1. So yang untuk yang ini ialah guna previous value F1 tambah 1. 1 tambah 1 kita dapat 2. Lepas tu ini ialah F2. 2 ialah 2 kan. So 2 dengan 6. So untuk dapatkan 6 F2 kita 2. So 2 tambah 4. Nampak tak? Kalau macam ni kita tak nampak pattern lagi kan. So kita perlukan nilai F4 ni. Okay, so sekarang untuk F4 tu ialah F3. Okay, untuk dapatkan F4, F3 ialah 6. 6 tambah berapa? 24. 6 tambah 24. 6 tambah 18. Okay, so macam mana kita nak dapat ni? Okay, so the idea here is how can we get so adakah tambah-tambah ni membantu macam tak nampak pattern kan? Okay, so sekarang kita tahu bahawa how can we get the pattern here is 1. 1 and the previous value is 1. So kita tahu bahawa kalau kita nak dapatkan 1 kali 1 dah 1 kan? Okay, so kalau kita tahu kita nak dapatkan 2 dengan menggunakan F1, maksudnya 2 kali 1 kita dapat 2. So yang ini kita tak boleh pakai. Maksudnya sebab kita tak boleh conclude something. So yang ni tambah-tambah ni kita tak boleh teruskan dengan yang ini. Dia tambah ni sebab 01418 kita tak nampak pattern. Tapi lepas tu kita tengok macam mana how can we get the next value from the previous value. So 1 times 1 we get 1. So 2 times 1 we get 2. 3 times 2 we get 6. Oh, so the idea now is we know that F n plus 1 is equal to n times F n. Okay, so this is the recursive step. Okay, so how can we check when we want to find 1, F1, so we use F0, right? So n is equal to 0. 0, F0 ialah 1. So sekarang 0, n ialah 1 sekarang. N ialah 1, so 1 kali 1 kita dapat 1. Jadi kalau untuk F2, 2 kali 1 kita dapat 2. So untuk F3, 3 kali 2 kita dapat 6. Okay. So we can use this. Okay. So now this is the recursive step. So the this example I will attach in the ULearn also. So this is the end for the lecture 7 and 8 part 2. Okay, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.